So thank you for joining us, guys. Appreciate it. My name's Lee Biggendon. I'm the co-founder of a company called Nephos Technologies, if you don't know who we are. Joined today by Dell and WekaIO, who are going to talk to you a little bit about their platforms as we go. In terms of agenda, what we're covering off, I'm going to do a quick intro into us and what we do, how we do it, why we think we're helpful, I guess. Going to pass the baton over to Derek over at Weka, and he's going to talk you through their parallel file system offering, how that works, etc. And then the baton's going to pass over to the team at Dell to talk about object storage and large-scale file data infrastructure, and how that interoperates with the Weka platform. Then we're going to close out with a little bit of Q&A. So anything you need, feel free to throw it in on the chat, and we can read them out and go through answers after. So I guess the first part really is about Nephos as an organization, just to give you a little bit of background into who we are and what we do, because you might not know who we are. So we've been going for nearly 10 years now, and we're effectively a data services integrator. So what we do with customers, it's really all driven around helping them solve complex data problems. And that ranges anywhere from the likes of Genomics England, where we re-platform their genome sequencing platforms and processing, through to some of the world's largest advertising organizations, to the likes of some capital markets and hedge funds, kind of high frequency trading platforms, those kind of things. Our focus really is on the data, so we tend to come at things in a little bit of more of an agnostic way, if you like. So really our focus is on making sure that our customers get the right answer to solve the problem. Now, one of the things and one of the reasons why we've kind of brought this together is increasingly within this kind of HPC world, we're seeing increasing demand for new ways of working, really, from an infrastructure perspective. Now, as an organization, our growth has been pretty rapid. So in 9.5 years, we've gone from nothing to 40, 50 customers, not only in the UK, but also we've been working with research organizations like DTU in Denmark as well, for example. We're pretty focused on what we do, and that kind of combination of customer first plus focus means we've grown at quite extraordinary rates, really, over 700% compound growth over the last 4 years, and that's found us in the FT top 1,000, so top 1,000 fastest companies by revenue growth in Europe. We cut across 3 markets, really, 3 different areas as a business. So one is, which I'm not going to touch on today, but data analytics, kind of AI, machine learning, those sorts of platforms. Another, which we've seen a massive rise in during the pandemic, has been around sort of data governance and compliance. So how do we get better insight into your data risk? Now, actually, for some of the universities we've been speaking to, this is quite a hot topic for them, probably outside of your remit on this call, but mainly as they look to secure their IP slightly more effectively. And the last, which we're going to talk about today, which is kind of where our I guess more of our heritage comes from, and where we originated from, is all around data storage and processing. And that's really about how do we better store, process, protect our data. And that better could be faster processing, it could be cost reduction, it could be both, could be more scale, whatever it might be. From an engagement perspective, we work all the way through the stack. So that goes all the way through from strategic consulting and advisory services. So how do we take you from where you are now to where you're trying to get to in terms of 2.0 version, through to provisioning of equipment, services, project delivery, all the way through to fully managed service at the end of that. So pretty full breadth. A little bit like a standard SI, but we like to think that we've got more flexibility as a smaller organization to give the customer what they want, rather than shoehorning what we've got on the truck. It's probably the best way of putting it. And that cuts across a number of organizations across various different markets that I've mentioned already. So I wanted to touch a little bit on what we are seeing in the market generally when we come into this space. And there's some common challenges that most of our customers are kind of reiterating to us. I think the first one is all around the data itself. It's getting bigger in every single dimension. Kind of volumes in general of data that we're trying to store and process are growing exponentially, as we all know. And a lot of that's being driven by the organization's desire to drive more value from it. So by kind of byproduct of that is that we're storing more data, right? And it's becoming more and more fragmented as we go, typically because traditional storage systems struggle to scale beyond the points that we're asking them to scale these days. And we want faster time to value. So what we quite often also commonly find is that a lot of organizations struggle with that kind of data wrangling problem, if you like. They're moving data from hot tiers to cold tiers for processing. They're struggling to access data across different networks because there's network bottlenecks and storage silos and system silos. So what we find is operationally that causes a big challenge for well, you guys really, in terms of the amount of time consumed by managing those data sets and the inefficiency of it all. And some of that's driven by budget cycle, right? We know that in some cases, quite a lot of cases, budget becomes available in spells, maybe for a certain project, for example. So we'll deploy a new platform for this particular project's requirements. But that doesn't talk to the systems that we've already got. So, we might put something like GPFS over the top to kind of aggregate those or whatever it is. Again, it kind of adds more and more complexity and difficulty when it comes to scaling. And also in some circumstances, I know speaking to some customers that there's a bigger desire to almost move to more of a service catalog model where these things are more easily cross-charged. And if not cross-charged, then at least looking to do things like show back so that I guess the people within the organization outside of IT appreciate the fact that there is actually a cost of storage and it's not all free. So quite a common challenge that we see across the piece. And also what we found is that quite often from a research perspective, pipeline can be a little bit unpredictable. Researchers tend to want to do what they want to do when they want to do it. And that can place quite a lot of strain on the infrastructure. And again, kind of heaps on the pressure when it comes to that kind of data management perspective, right? So alongside that, we've kind of seen this change in dynamic as well from a cost perspective. If you look at barriers to delivery, quite often cost is a large proportion of it. No one's getting that much more money or people, but they are getting asked to do a lot more with the data and the infrastructure, right? So how do we get better economics around that? Now, traditionally, what most people have done is put that maybe all on all flash, or try and put in one scale out platform and manage the economics that way. But there's quite a different challenge with that in terms of when you look at the data profile itself. Quite a lot of the data sets that are in play aren't actually hot. A large proportion of the data sets are cold. So at that point, we're running effectively cold data on hot tiers, or we're pushing it off onto tape because we need to protect it. And then we have to go back to the tape. We have to bring it back. We have to rehydrate that for people to then use it. With the advent of kind of objects and cloud infrastructure, cloud storage, blob storage, object storage, whatever you want to call it, we're seeing that dynamic change slightly. So what we look to do as an organization is kind of leverage object as a capacity tier underneath some high performance tier. And the goal of that really is to drive the best of both worlds. We want to get both. We want our cake and eat it. We want performance where we want it, scale where we want it. Quite often that's complicated further by the fact that actually we've got all of these pockets and silos of data sets, right? And inevitably, when you start looking at how do we then apply data protection to it, how do we archive it, how do we make sure that in the event of failure, we're not going to lose our data, our critical asset. And a lot of cases that results in people storing at least 5x the amount of data that they actually need. When you look at duplication, replication of data sets. Both of those two things, so that cost dynamic and the overall complexity and silos that we see within the infrastructure, make it really, really hard to scale. And I guess for you guys, makes it quite hard to do something that's a little bit more predictable and a little bit more consistent. Our approach tends to be, as I mentioned already, looking at this kind of two-tier model, if you like. So what we look to do is understand the profile of data that we're storing and how it's being used, and we map that to the storage infrastructure. When we look at customers in the main, depending on what you're doing with it, obviously, between 15 and 30% of the data that's around is hot. It's being accessed quite commonly. It's being used. It's hot. It needs that high performance, right? But the remaining kind of 75, 70%, 80% of that data set, it needs to be available. The research community needs to be able to get hold of it and do things with it, but more on demand. So it's kind of more nearline than it is super fast, right? So what we look to do is create this two-tier model. And that's what we're going to, the guys at Weka and Dell are going to talk about a little bit. We want performance where we want it for that component part. And that's what Weka provides us. It gives us a high performance parallel file system that gives you that kind of, I guess, higher cost per gig, if you like, in cloud parlance, across the piece to give you performance where you need it. What we then leverage is an object here behind it. So we snap down to objects so that we can drive scale out using typically erasure coded object storage if we can, to drive scale and resilience over our data sets. By combining those two things, that gives us commercially the best of both worlds, and it enables us to scale both of these components out independently. Ends up looking something like that. Now, as I say, what we do as a business is help design, implement, integrate those component parts and work through it from a cost modeling perspective as well for you. So hopefully that gives you a little bit of context, a little bit of background. On that kind of point, I'm going to hand over to Derek, and he's going to walk you through the Weka platform.
All right, so hi everyone. Pleasure to share some information with you this afternoon on the Weka FS and Dell Technologies solution. My name's Derek Burke. I've been at Weka for almost 3 years now. It'll be 3 years in December. I've been kicking around in high performance computing, high performance storage for about 21 years now, starting to feel a bit old. What I'll do here is I'll just give you one slide on who we are as a company. I think it's nice for you to know who we are and what we're doing. One quick slide on the customers, use cases that we are accelerating, and then we'll jump a little bit into the technology, what it looks like when we're deployed with Dell, and then we'll hand over to the Dell team. So let me jump in here. So Weka as a company was founded in 2014. Our corporate headquarters are Silicon Valley, California. Engineering headquarters are in Tel Aviv. You can see the Tel Aviv office in the background of the slide here. And we were founded with the goal of addressing the scalability and performance challenges of unstructured data. And our founders spotted what they saw as a gap in the market for a parallel file system that was built and designed for flash storage technology. So they created our product, the Weka file system, Weka FS, and we've been having a huge amount of success with that product. In terms of revenue growth, new customers, we grow quarter on quarter on quarter, and the company's seen a huge amount of success at this time. And we've had some investment from some huge technology companies. So NVIDIA is an investor in WekaIO. They saw that we have a unique capability in keeping very data-hungry GPU compute nodes busy with data. And Mellanox, before they were acquired by NVIDIA, invested in Weka because they saw that we could saturate high-speed networks with data to keep those data-hungry compute clients very busy. We've also had investment from Seagate, Western Digital, Micron, etc. In terms of our customer base, we've had a lot of success in the commercial space. In fact, 9 of the Fortune 50 companies in the USA are using the Weka file system to feed data into their compute clusters for research computing or for machine learning. A lot of success in finance, life sciences, manufacturing, oil and gas, and in the public space, a lot of success in government, departments of defense, academia, and of course, public research. Our partner ecosystem is really broad. So we are software-defined storage. We work with hardware partners like Dell to produce reference architectures which are validated and tested designs with their technology. And we'll talk a little bit about some examples with Dell today. Just last week, it was announced that Weka is a visionary on the Gartner Magic Quadrant for distributed file systems and object storage. We see ourselves as the future of file storage, and I'm very happy to tell you a little bit about our product today. In terms of the customers that are really benefiting from Weka FS at this time, it's mainly in these industries and use cases. So in finance, we've had a lot of success in the systematic algorithmic trading space, particularly because we've got fantastic small file performance, fantastic metadata performance. They really need that when they're crunching tick data. A lot of success in fraud and risk analytics. And also we're seeing a real convergence of business intelligence and traditional business intelligence analytics with machine learning that's disaggregating compute and storage. In life sciences, most of our customers in that space have large amounts of genomics data or data produced by other large laboratory equipment like cryo-EM systems, data being used for disease detection, drug and vaccine discovery, precision medicine, etc. In the AI machine learning space, we've got 12 autonomous vehicle customers across the globe, lots of customers in the life sciences space, training algorithms to detect anomalies in medical images, and customers in the manufacturing space, training algorithms to detect anomalies in parts before they leave their factories. Just some examples, the world's largest electric vehicle manufacturer uses Weka, and world's largest display manufacturer, world's largest semiconductor manufacturer, all use Weka within their AI machine learning data pipelines. In traditional HPC, we've got a very large and growing presence in the US DoD, lots of academic customers, manufacturing around both fluid and structural analysis, and in the oil and gas space, predominantly around seismic processing and some machine learning there as well. All of these customers really benefit from their applications processing jobs faster. And that's exactly what Weka FS enables them to do, enables them to feed data into the processing systems faster than any other file system. This is a quick look at how the solution's deployed. So all of our customers have NVMe servers. These are Intel or AMD-based servers with NVMe devices inside. And we add the Weka software on top. It's deployed onto those servers inside containers and standard LXC containers. And at that point, we have created an all-flash NAS, an extremely fast all-flash NAS. In fact, when we compare our performance per rack unit versus alternative solutions, we're often up to 10 times faster. And the reason is that we've built and designed the file system to unleash the highest performance from flash storage and deliver that over the network to your compute clients. In terms of network, we support both Ethernet and InfiniBand. Your compute clients would generally access data on the Weka storage cluster using our POSIX client interface. It is lightning fast. So we tested with the latest, largest GPU nodes. These have 8 A100 GPUs and 8 200 gig network links per client. And we showed leveraging NVIDIA GPU direct storage technology, 162 gigabytes per second of throughput, 1 million IOPS, file IOPS, delivered to that client over a single mount point to the file system with all IOs at sub-millisecond latency. So our latency on 1 meg IOs is probably is sub-millisecond. Our latency on 4K IOs is probably around 200 to 300 microseconds. The reason our latency is so good is that the Weka POSIX client sits in user space and leverages a library called DPDK to communicate directly over the network to the compute cluster. Sorry, to the storage cluster. The storage cluster itself is using DPDK to communicate between the nodes directly over the network, and also using a library called SPDK to avoid the kernel for IO operations and communicate directly to the NVMe drives. What we're actually doing is we're taking a file, we're splitting that file over into 4K chunks and distributing it over multiple network connections across multiple NVMe drives in the cluster. We're then protecting that data at the back end with erasure coding. I want to emphasize at the back end, we're not doing erasure coding at the file level. We're protecting it at the back end with erasure coding. Our erasure coding starts at 4+2 and goes all the way up to 16+2 or even 16+4. So that's 16 data bits +2 or +4 parity bits. The failure domain within your Weka storage cluster is the server. So depending on the number of parity bits you have, +2 or +4, that dictates how many servers you could lose without any impact to data availability or system resiliency. We have something that's very, very unique when it comes to network attached storage, because we also fully distribute the metadata across all these NVMe drives. And we also protect that metadata with the erasure coding. Running on each of the NVMe servers in your storage cluster is what we call virtual metadata managers. You can have multiple of these running on each of the NVMe servers, and it's entirely configurable by the system administrator. And they are not tied to the underlying namespace structure. So they're not tied to a particular file system or directory or subdirectory. What that means is that our metadata is fully distributed, the performance is massive, and when we compare it against alternative solutions, we're often an order of magnitude faster. If you think about what we're doing here, we have fantastic metadata performance. Our small file performance is great because we naturally work at 4K IO sizes. Our large file performance is great because they're just distributed in parallel across lots of NVMe devices over lots of network links. In fact, we support up to 4 petabyte single file size, which is just huge. And all of this without performance tuning. Weka is very, very different to, if I can do a comparison against Lustre, because this is an HPC audience, I'm sure some of you are familiar with Lustre. With Lustre, you've got your JBODs, you've got to set up your LUNs, you've got your controllers, object storage servers, metadata servers. Often you're setting up LUNs and storage pools and optimizing for performance. There's a lot of tuning involved. Certain applications that are small IO or metadata intensive might struggle for performance and affect the performance of your cluster. Weka is not like that at all. There's no underlying file system here. There's no ext4 or ZFS under the covers. We have our own SSD agent that optimizes data placement for NVMe drives. There's no LUN set up. There's no controllers. There's no object storage servers. There's no dedicated metadata servers. Once you have your servers running with Linux, we come along, we add the Weka software in the containers, and you'll be up and running serving IOs within a couple of hours. It really is that simple. There really is no performance tuning required to get the native performance that we can deliver. I'm showing just one compute client here, but our customers generally have tens, hundreds, or thousands of compute clients that are concurrently accessing data on the Weka storage cluster. It doesn't matter to us if they're bare metal Linux, if they are virtualized with OpenStack or VMware, or if they're containerized with Docker or Kubernetes. In all cases, they can use the Weka POSIX client interface for lightning fast access to the data. But we also support NFS, SMB, and S3 access to the same data in the same namespace. If you want to scale your Weka cluster, your NVMe cluster, you can do that by adding drives into any free drive slots that you have, or adding one or more servers into the cluster. You can do that with just a couple of clicks through our user interface, a couple of clicks of your mouse, and you can scale out the cluster. It can scale to hundreds of NVMe servers. The really nice thing about Weka is that everything runs evenly on all the servers in your cluster. Data and metadata are distributed evenly. Cluster management, file system management, and metadata management all run evenly on each server. So every time you add a server or servers, you scale everything linearly. Now, some of our customers have tens of terabytes of data, but some have tens of petabytes. And for those with larger capacity namespaces, we give them the option to add a spinning disk tier behind the NVMe flash tier. That spinning disk tier is based on object storage. And what we allow our customers to do is to set up file systems on their Weka storage cluster that have tiering policies that dictate when data is automatically moved from the flash tier when it becomes colder into object storage. The metadata always resides on the NVMe tier, always remains fast. Both tiers are presented to your clients and applications as a single shared namespace. All writes always land on the NVMe tier. If there's policies on the file system they land on, then the data will be moved down to the object tier when it becomes colder. Any reads will be fed back to the clients from the NVMe tier. If the data is on the object tier, it will be brought back to the NVMe tier automatically, served to your clients and applications. We can do byte range reads from the object tier. If we see a sequence of byte ranges, we'll start to prefetch data. We don't have to bring whole files back from the object tier. We can pin data to the NVMe tier. We can even tie in with job schedulers like Schlurm, for example, to make sure that data sets that are on objects are brought back to NVMe before you kick off a large job. The object tier itself can be on-prem and in the public cloud. So some of our customers have an on-prem NVMe flash tier, an on-prem object store that they tier data into, but they use one of our features called Snap to S3 that creates bundles that can be pushed into the object tier, even in the public cloud. And those bundles can then be used for backup, disaster recovery, and even for bursting into the public cloud. If you think about it, this is a fantastic way to leverage on-prem for your high performance workloads where the data is very transient, but leverage the public cloud for use cases like backup and DR where the data is generally very, very static. And you know that in the public cloud, you get charged for data movement, right? So that's a really good way of using a hybrid environment for use cases where it's most optimal. Our customers that have both tiers generally have about 5 to 20% of their data on the NVMe tier and the remainder on the objects. That allows them to amortize the cost of their capacity across a small amount of flash, large amount of objects. But that small amount of flash is a high performance window into all of the data, and the data movement between the two tiers is fully automated. This is just a quick look and an example of what a WekaFS and Dell solution would look like in a production environment. So here you have your Dell compute clients running the Weka POSIX client interface, giving them access over the network to the NVMe cluster, which is represented here by the Weka Flash tier. We're showing HDR InfiniBand here. It could also be different InfiniBand speeds or Ethernet. The NVMe servers here could be AMD or Intel based. We're showing some Intel ones here as an example, but they could be either or. And then we're showing ECS object storage behind the NVMe tier for tiering, and could also be a target for those snap to object bundles that I mentioned for backup and for disaster recovery. Again, everything presented as a single shared namespace to your compute clients and to your applications. By the way, I should say that the ECS object storage doesn't have to be entirely dedicated to the Weka. It can also be used for other use cases in your environment. As you know, object storage is becoming more and more common across different use cases. So you could allocate a bucket or buckets to Weka, and then other buckets to other use cases that you have in your environment. And of course, the Dell guys will give you a deeper insight into ECS. Just a couple of features that I haven't touched on. So we do support NVIDIA GPU Direct storage. We were the first production file system to do that. We've got a Kubernetes CSI plugin as well. We've got instantaneous snapshots without any performance penalty. We use redirect on write to do that. We've got tiering or snap to S3 bundles for backup and DR. We've got at-rest and in-flight encryption. We can even tie into your key management systems to further encrypt our keys. We've also got secure organizations that we use for private multi-tenancy within the same namespace. So create organizations, appoint sub-administrators, give them a capacity limit, and then the sub-administrator can create their own file systems within that organization and authenticate users. No one else can see what's going on inside that organization, either the structure of it or the data or anything. We've got end-to-end checksums as well. So that's another great feature. Lots and lots going on with Weka. I won't dwell on this due to time. Okay, so just in summary, Weka is really, really simple to install and manage, and there's no tuning to unleash the performance that we can deliver. A good example is one of our customers in the UK, Genomics England, actually manages a 60 petabyte Weka namespace with just half of one system administrator's time. And we've got fully integrated tiering, backup and disaster recovery. And we've got Nephos as a partner that's your single hand to shake for consultancy, infrastructure and services. In terms of performance, we deliver up to 10x the performance per rack unit versus alternative all-flash NAS solutions. We also are naturally optimized for very diverse I/O workloads. We can also saturate high-speed networks into your compute clients to maximize your investment in your compute systems. And in terms of scale, you can actually scale out using different infrastructure to the initial installation. And we can also, you could also add more modern nodes in the future and decommission your existing nodes, and Weka will automatically move data over so you can do rolling upgrades to newer infrastructure without migration or downtime. We support exabyte scale. We can have billions and billions of files in single flat directories if we want, because we've got great metadata performance, and we extend into the public cloud. And we can scale performance and capacity separately, right? You can scale your NVMe tier as required and your ECS tier as required. And again, that ECS tier can serve multiple different use cases. And with that, I will stop there and hand over to the team.
Great. Okay. So Roger Dowden, I work for Dell Technologies. I've been there for 7 years now. It seems to be marching on. Like most of you, haven't been out to see customers in the last 18 months. I did go and see one a week or so ago, but that's it. Hopefully you guys are having a good experience these days, and we won't keep you too much longer on this Zoom session. So as Derek mentioned, there is, this is an overview of the Weka architecture, and he did have some nice drawings showing us having Dell Tech powered servers at this rate. Yes, you can certainly have them at the top end as well, but maybe you've got DG boxes at the top here or something, the NVIDIA boxes. But again, we've got GPU-based servers as well, but I'm not in the server side of the team, so I'm not going to push that too much. Obviously, we need a large object store at the back end, and that's where what I'm here to talk to you about today. That would be our ECS, sometimes previously known as Elastic Cloud Storage, but pretty much everybody calls it ECS these days. So it's a clustered object store built out of servers. The servers that were mentioned, there is a config, like a predefined, pre-tested config, a larger and a small version of it. So you can choose this side of it. You can get pre-built, have all the bits in, supported, etc. At a config that will work. So we certainly support that from a server side of things. From the object store, the enterprise level object store, we're talking something that we've built. We've been doing this for an awful long time. Centera, I was with a partner many years ago and sold Centera. It was effectively the first commercial object store that was made available. It used a protocol called CAS, content addressable storage. It was way before S3 was invented or became a standard as such. So effectively, the way this worked was you wrote an object to via the API. It did a kind of a MD5 checksum and gave you a number based on that. And to get your object back, you had to give it that checksum type number. It included the date and things like that. That's why it's not quite an MD5 sum. But effectively, that gave you a worm-based object store. You couldn't change it because the MD5 checksum would have changed. So that's where it started. This was way back early 2000. A few years later, we built on that. S3 was available at that point. This is, the content addressable storage was you put the object in, you couldn't update it, modify it. So we added read-write workflows, and then you can have multiple sites. Global namespace came into effect, multi-tenanted. So we brought that out for a while, and then in 2014 it was redesigned as a new product called ECS, which supports S3, Atmos, and Swift protocols. It also still supports CAS. You can actually, if you go back to this, the nodes here were 1, 2, or 4 terabyte nodes then, way back then, and a 10 or a 20 terabyte system was a big system back then. Obviously now it's multiple petabytes, but we still have, there's still a few customers who've got them sitting there running in the corner, and we can put ECS in front of that. So what I'm trying to say there is we've supported those customers all over that, for a significant period of time, and haven't left that customer in the lurch as such. So 2014, we came out with this new product called ECS, and there's, as was mentioned, it's been in the top right corner of the Gartner quadrant for a number of years. My PC's giving me the spinning wheel of death. That's not helpful. So we have a very large customer base, over 3,000 customers running ECS. 34,000 plus systems have been shipped, and over 3 exabytes of capacity. That's a huge amount of capacity. One of the things that's very focused on, originally the object stores were designed as archive stores, that was originally a big target for them. So data durability is very, very important. So there's a lot of hardware design and software design around that. We support over 100 ISVs. So as Derek mentioned, if you want to use it for something else, rather than just the Weka as the back end, you could use it as a backup target, for example, or another application, just to set up multiple namespaces, multiple buckets, etc. So lots of other supported software companies out there. And from an expandability point of view, you're effectively limited to the how much data center space have you got, heat and power, etc. So something that you can start with, you can start reasonably well, you can start very small, 60 terabytes, and go from there. So current family tree, like I say, EX300, look, Dell PowerEdge servers they're based upon. So you could have, you could start at 60 terabytes as the entry level. This is, you can have 8 drives in here, 1, 2, 4, 8 or 16 terabyte drives. So you start off with those up to 16 in a rack, and just keep building out. But if you've got a larger starting point, maybe start at the EX500, 12 or 24 drives. Again, the larger drives only in these 8, 12 or 16 terabyte drives. So, sort of like a mid-tier, middle ground kind of capacity, 6 petabytes in the rack. And then we've got our deep high density nodes. You're looking at 11.5 petabytes in a rack, 2 or 4 single or dual node nodes with 45 or 90 drives per node. And then of course we've got all flash. This is released earlier this year, the EXF 900, 24 NVMe drives. So if you just have a small S3 requirement that doesn't need, you don't need InfiniBand connectivity, you don't need that parallel file system, but you just need a fast object store, we have an option there too. Oh, sorry, go 1 second. We do also have a, we're going to be releasing a new node type before the end of the year, an EX5000. It's again, it's 100 drives in a node, so 1.6 petabytes in a node raw, and it doesn't need the deep cabinet, so that's something to keep an eye out for. So as I mentioned, we're very high, data protection is very high on the agenda. So typically, as objects are written to the cluster, we triple mirror it immediately. And then in the background, we erasure code it, because obviously triple mirroring is quite expensive from a storage perspective, or storage utilizations perspective. So we triple mirror it, and then we erasure code it in the background. We've got a couple of options. If with a Weka solution, we'd typically use an active archive, which is a 12.4 erasure encoding model. But if it's a colder long-term archive, pure long-term archive type workflow, we'd use a 10.2 erasure coding model, which gives you more capacity per node. We also support XOR if you've got multiple sites. There's another site I'll talk about that in a second. But effectively, if you've got 3 or more sites, rather than doubling the capacity because you're replicating each time, using erasure coding, we can improve that raw to usable ratio again, which saves in cost per terabyte. So yeah, various different levels of protection. There's no single point of failure on a node. So locally, we're doing erasure coding to protect the data within a rack and within from a node perspective and within a rack perspective. And then we're using XOR, or just if you've only got 2 sites, it's just replication, just to give you that extra site protection. Oh yeah, I've forgotten that builds. So the 12.4 on a 5 node cluster, you can lose a node or 4 drives and still haven't lost any data. So depending on how big you're going, as you add more nodes, you get better, higher levels of resilience as well. So as I mentioned, if you're going to go multi-site, we can do active-active for multi-site. I've seen some architecture drawings from Weka with a cluster, primary cluster, doing the majority of the work, but maybe you've got a secondary site that also needs to do work, and you've got active-active access to that data, the object store between the two. We use geocaching to improve performance, but we also use strong consistency. And what that means is when you write to a node in a cluster, that object gets given, that cluster has effectively got ownership of that. And so if another cluster in a different location wants to read that, wants to write that data, it checks that it's got the latest copy across the network, and to verify that it's got the right copy. Otherwise, there's other systems out there that don't use that strong consistency, and you can get write clashes, etc. And that's not the sort of thing you want in a storage system. We don't do erasure coding across multiple clusters. We use the XOR. So if you write an object to site A, you write an object to site B. At site C, if you copy A and B to it, do an XOR, you've got C. You don't need a full copy. So that's how we get the reduced capacity across multiple nodes, multiple sites. Also, as was mentioned by Derek there, writing small objects and large objects need different different ways of handling them. So what we do on an ECS is large files over, so if it's a large files, we just write those, triple mirror them initially, and then erasure code them, and just to give you high performance throughput. But on a smaller, if you're doing lots of small IOs, writing that to the disk is a challenge. So effectively we have we call it box carting, but it's effectively a write coalescer. So all small objects are written up to 2 meg, and then we do a 2 meg write to the back end. So that improves the performance for both small files and large files. So very efficient from a management perspective and a performance perspective. We all know, if you look at any of the research data, yes, there's millions of small files, but there's also millions of large files as well. And so you have to be optimized for both. So what are our main features and functions? Why do people go for an ECS rather than some of our colleagues, competitors? We have, it is a scale architecture. You just keep adding nodes, fill up a rack, add a rack, keep adding racks. There's no limits on capacity, numbers of objects, file sizes, or nodes. It is limited by the size of your environment, the physical environment. You can go across to up to 8 sites. We can do this active-active with the XOR. As Derek mentioned, you can have different namespaces. So if you've got, I don't know, we've got some customers that have done forensics, and they've got tons of disks that they came from a service provider, and they need to import those, and we can just ingest that into a bucket. Multi-protocol, we can still we can access data via S3, NFS. There's a Windows plugin. Still support CAS from a long while ago. If you need data encryption at rest, we can do that. That's just a turn on. Switch on the function. And we've also got some, like I say, we've got some SSD versions. There's an SSD metacache option for every node, and you can add custom metadata as well. That's outside of the S3 standard, but we can certainly support that. And that's pretty much me, I believe. Yep. So do you want to go through the, I think there were some questions in the background, not necessarily for me, but.
Yeah, I'll just close off, and then we'll
yeah.
And then we'll pick the questions up.
Okay.
Thanks for that. Yeah. Excuse me. Thanks for that, Roger. So I guess just to kind of wrap up, and just to give you a little bit of an example, how do we help? So Derek mentioned it earlier. A lot of our work is done with customers to work out how all of this stuff gets architected, delivered, and how that's going to suit the environment. So as part of that, we work across the HPC aspect, the storage aspect, networking, etc. And what we have is effectively a predefined engagement model that helps us go through that to understand what the right answer is, what the right commercial models are, etc., etc. Broadly speaking, without going through each of the component parts, that all begins with understanding the data landscape. So what have you got? What are you trying to do with it? What's the profile of the data mapped against the workflows? So how do your researchers actually work? Sometimes it's not always understood. And then we take those elements and we develop a strategy thereafter. And that's really then designed to drive a deployment plan and kind of program thereafter. To give you an example, so live example of a customer we've got here in the UK that combines Weka plus Object. And effectively what we've done there is map across those NVMe nodes in one primary data center with, initially it was 1.3 petabytes worth of usable on the Weka side. Over the last 3 years or so, that's grown to about 4 petabytes. The initial object storage tier was around 21. petabytes across 2 data centers, and this might answer one of the questions that have come in actually. Across 2 data centers originally. Now, what we've done is we erasure coded across 3 clusters in 2 data centers because originally the 3rd data center didn't exist. That was originally at 21 petabytes. We migrated the existing 20 petabytes of research data out from the existing systems onto Weka. So effectively help the customer maintain both systems for a period of time. We snap that data down to the object tier for our resilience. And as I say, that was 21 petabytes. That's since grown to about 60 petabytes in the backend object tier. But the customers only had to expand the performance tier, the more expensive element, sorry, Derek, up to around 4 petabytes. So actually, from a kind of cost per gig usable perspective, economically, it's a lot friendlier, I would say. Over time, what we've done is we've helped the customer to bring online a 3rd data center, physically shifted one of the logical clusters that was in the 2nd DR center to that 3rd data center, to then give them true kind of disaster recovery, if you like, across those 3 locations. In the DR center, we run a smaller version of Weka for DR. So it's on a smaller footprint, it's all across the same environment, but a smaller footprint for DR purposes, for critical services that need to come back online. The net impact of all of that from what the customer's seen is massive performance gain compared to what they had previously, in the order of 10x. Interestingly, the bottleneck and another program that was running in parallel was upgrading all of the HPC clusters themselves. So aside from the storage, that's very, very nearly completed. So once that has done, we'll expect to see a much bigger performance gain there as well. Once the HPC clusters are kind of up to speed, if you like, they were quite aging. All of the infrastructure was quite aging, to be fair. But as part of that, we've seen up until year 3 a 75% cost reduction over the piece. Once we hit year 5, because we work with the customer to develop their cost profile based on their growth patterns. So the plan was to go from 20 petabytes to 120 petabytes over 5 years was their predicted growth. They're slightly ahead of that going into year 4 of where they were predicting to be. What we see is as we grow, because we effectively will end up scaling out the object tier more than the performance tier, is that 75% becomes closer to 90%, because we're driving economies of scale with it. And what it also means we've been able to do is remove the scaling limits. So because we're leveraging objects, because Weka is scale out, we effectively are then able to scale those 2 things incrementally and independently with no limit. So there's a massive benefit in terms of growth plan there. There is a second part to that story as well, in terms of part of the future plan is to extend that into AWS as well. So they've got certain customers or certain partners they work with that are landing data in public cloud. And what they want to be able to do is effectively land that on the same platform. But obviously, when you start looking at 20, 30, 50, 100 petabytes worth of data, realistically, moving all of that lock stock into public cloud is economically challenging. And not only that, but also you then get into the realms of, okay, well, how do we bring it back if we decide to exit? What's the impact on network, et cetera, et cetera. So Weka does actually give us the ability to leave the data in object on premise in the data centers at volume, and then effectively present up into cloud the performance, the area that we need for performant processing. So from a future-proofing perspective, it gives us the best kind of hybrid model to work through. So I guess just to close out, what can we do next? If it looks like it's interesting, obviously we have a team of people behind us, much smarter than me, that we can give you access to talk through it in a little bit more technical detail. Platform demos, test drives, all of those sorts of good things we do. So that's effectively what I think we'll leave you with. We've got a couple of questions that we'll cover off.